Hello students, how are you? I hope you are doing well. Today I have come with two questions based on thermodynamics which were asked in the second half, that is the afternoon shift of 24th January 2023 JEE mains. So let us discuss them one by one. Here is the first question you can see. Let gamma be the ratio of molar specific heat at constant pressure and molar specific heat at constant volume of a monoatomic gas, and gamma to be the similar ratio of a diatomic gas. Considering the diatomic gas molecule as a rigid rotator, the ratio of this. Now here we have to understand that the value of gamma in terms of degrees of freedom is this. I hope you know this formula. The value of gamma in terms of degrees of freedom. Here F is the number of degrees of freedom. Okay. Now for a monoatomic gas, F is 3. Is it? For a monoatomic gas, degrees of freedom is 3, corresponding to each of the x, y, z axis. So you have 5 by 3. Now coming to the diatomic gas, it is clearly mentioned that we have to treat it as a rigid rotator. That means what? We have to ignore the degrees of freedom corresponding to vibrational motion, because we know in general any gas molecule will have three types of degrees of freedom, one corresponding to transitory motion, the other corresponding to rotatory motion, and the third corresponding to vibrational modes. Each mode can have several degrees of freedom, that you know. Now here a diatomic gas molecule is just like a dumbbell, the atoms remain bonded at high temperatures, sufficiently high temperatures, they start vibrating. So additional degrees of freedom become activated, but all those things have to be ignored as per the question, because it has been clearly mentioned that we have to treat it as a rigid rotator. So that means we consider only the transitory and rotatory degrees of freedom, and they are 3 plus 2, that is 5 altogether. So gamma will be 1 plus 2 by 5, which is 7 by 5. So when you take the ratio gamma 1 by gamma 2, you will get 5 by 3 into 5 by 7, that is 25 by 21. So third option is the correct option. Then let us move to the next question, please. Sorry. In an isothermal process, the change in pressure and volume of a gas can be represented for three different temperatures. Now, isothermal process means when temperature remains constant. For a given mass of a gas at constant temperature, Boyle's law becomes applicable. Is it? If you write the equation of state is PV equal to nRT. Since n is constant, and for a given mass of a gas, n is also constant and T is constant as per the process, that is isothermal change. So therefore, this is constant. So pressure varies inversely as volume. When two quantities vary inversely with each other, then the graph between them is a rectangular hyperbola. You can see it is just like this. Rectangular hyperbola. The graph touches the two axes at infinity. They tend to get closer and closer as you move away and away from the origin. So that is a rectangular hyperbola. That is known as a rectangular hyperbola. So that means you have either option 1 or 4, any one of them. Then in order to ascertain which of the two is correct, we need to pay attention to this condition. T3 is greater than T2 is greater than T1. Now you can see that the product of pressure and volume must be equal to nRT. So higher the temperature, more will be the product PV. So if you choose certain points, suppose you choose one point here and another point here on this graph. So corresponding to T1, look at the volume and pressure. If you multiply, you will get less value. Whereas corresponding to a point on this curve, look at the volume and look at the pressure. Here both volume and pressure are more, so the product will be more. So T3 must be more, and that is correct. So this should be the correct answer. If you take this, then you will see it will get contradicted, because for T3, product of pressure and volume is less. Look at the value of volume and pressure, it's very less. But T3 is given to be more, so this cannot be the answer. So correct option is the fourth option. I hope you enjoyed the video. Please subscribe to my channel and also hit the like button. Thank you so much.